Okay, so number 4, 5, and 6 are all very similar. So if we just follow along for number 4, the other one should make sense, 5 and 6. So when you have the normal distribution curve, you will be given this on the quiz. Each section has its own amount, its own percentage, and it adds up to 100. So, right, it splits down the center. You go at 34, then 13.5, then 2.35, then the last little chunk is 0.15, 0.15. Anyways, so for this problem, it said that it said find the difference of the data range of the sections. And so if they tell you an increment, like they say that the interval is 99.7%, you know that this whole yellow region is 99.7%. If you add up 34 plus 34 plus 13.5 plus 30.5 plus 2.35 plus 2.5. If you discard the ends, right, if you don't include the 0.15 and 0.15, all of this green right in here that I just highlighted, that's yellow in here, that's 99.7%, right? That's the 99.7% region. So then if they say in that region, the lowest number is 12 and the highest number is 36 in that region. And then they say, what is the standard deviation? Standard deviation is the equal amount between each increment, right? Between each slash mark. So if on the whole distribution curve, there's 8 segments, between 99.7 section, there ends up being 6 pieces. So how we find the standard deviation, or the equal amount between the pieces, we take the difference. So you do the end, 36 minus the start of that segment, 12, divided by the number of sections, and that will give us 4. So that means each section's worth 4. Therefore, the standard deviation is 4. I wanted to point something out before we start. For numbers 6, 7, and 8, and 9 to 16, because those are also similar, it's important to understand what the answer, what we want when we say, do we want percent, probability, and actual amount. So if it says percent, you can look at that normal distribution chart. I'll give you all the values in terms of percents, right? If you want to turn it into a probability, for example, you would take 34% and you would move the decimal 2 to the left. So here we have the percent symbol, and then beneath it, probability. Now, if you're looking at a z-table, the values you see there are decimal form, so you would use that for probability. If you were going to convert, you would just move decimal 2 to the right to get a percent. Remember, the z-table always shows you the decimal values, the probability, always for less than. So be careful if it says greater than in the problem, you always need to do 1 minus the value in the table. And the last thing you'll be asked is to find a specific number of something. So out of 36 students, how many had X, Y, or Z? So you first need to find the decimal answer, the probability of that certain amount of people having something. But then you take the probability, the decimal, and then you multiply by the original number of items or people. So for example, if I said half of 36 people have pencils, you would find the decimal, so 0.5 times the total, the original, and that's why we would get 18. So 3 things we'll ask: percent, probability, we write as a decimal, and an actual number of items, where we take our probability, aka the decimal answer, and we're going to multiply by the original total amount. And just remember that when you have a z-score, x minus the average over standard deviation, that number isn't your probability. Let's say that number is 0.6, right? That's not your probability. That's the value that you use to go to the table, and the table, the z table, gives you the probability. So you would then look for 0.6 in the table, and that's where you would find your answer, your probability, which you could turn to percent. Okay, so for number 6, the mean was given. Always write down what's given. I also always like to draw the curve. And then standard deviation, the number of units between each increment is 13. So if it's 50 here, if we add 13, we're at 63. If we take away 13, we're at 37. If we add 13 to 63, we're at 76, and so on and so forth, right? And there's 8 increments in total. Now if it says, what's the percent between 11 and 89? Well, that's in this purple region. Between 11 and 89, if you add up all those percents, 34, 34, 13.5, 13.5, 2.35, 2.35, you would end up getting 99.7%. And so that's also in purple. If then, for number 7, it's linked to the same problem, it says, what's the probability, so we want our answer as a decimal, for at least 37 days. We're looking at values, up on top I have them in green, we're looking at values that are at least or to the right of 37. So in my chart I would add up all the percentages first. I know that this is all 50 added up, plus 34 would be 84, so it'd be 84%, but because I want probability, I just converted it to decimal by moving 2 to the left, so it's 0.84 is my answer. Then, how many, in blue, I'm still using the same curve above, that's right next to the number 6. How many, I first need to find the percent and then multiply by the original total. So it says, how many are between 37 and 63 days. So I look up here between 37 and 63 because I first need to find a percent. And I know that these two regions make 68%. But I don't want a percent, I need a decimal. So it's decimal times original amount. So it's 0.68 times, they told us originally that there are in total 250 homes. When we multiply, that's 178 homes lie in the region to sell between 37 and 63 days. And then for number 9, it says no more than 24, meaning we want to only look to the left of 24. Now to the left of 24, those are the two small regions. Those two little regions right in there are 2.35% and 0.15%, which is 2.5%. So we would say 2.5%, we need a decimal, so we would need to do 0.025 if we move 2 to the left, times the original amount of homes would be about 6 homes. Just a reminder on the quiz, you will be given the normal distribution percentages numbers. You'll be given your z table. You need to know, here right in red, you need to know the formula to find a z-score. You need to know how to use your calculator. I cannot help you with either of those.